Right. Hello, everyone. Welcome to the session, Running Serverless at the Edge. Thank you all for being here, especially considering that this is perhaps the last session of the day. So thank you again. My name is George John. I'm a product manager with AWS Lambda at the Edge team. I'm very excited to have Tyler Foster from Sentient, who will be sharing Sentient's use case for Lambda at the Edge and their journey. So before we get started, quick show of hands. How many of you are using CloudFront today? I would say probably 50% of the room. How about Lambda at the Edge? OK. How many of you have heard of Lambda at the Edge? Not really using it? OK, 50%. So hopefully, today, by the end of the session, you will have a good understanding of what Lambda at the Edge is. So but first, we'll take a quick look at what this is. And then we'll do a deep dive into Lambda at the Edge. We'll take a look at the programming model. What are the event triggers that are supported? We'll take a look at multiple customer use cases for which customers are using CloudFront and Lambda at the Edge. And then we'll have Tyler share Sentient's journey to CloudFront. He's going to go deep into architecture, going to share some of the best practices and lessons they learned as they migrated. So between Tyler and I, we do have only an hour, so there's only so much we can cover. But there are many interesting Lambda at the Edge sessions happening throughout the week. So if you're interested, please do make a note of these. And also, we have a lot of content, and we want to make sure we get through all of that. So I would request to hold off all questions till the end. Both Tyler and myself will be hanging out here if you want to come forward and ask any questions. And also, we'll be sharing our contact details on the last slide. So if you want to reach out to us offline, you can do that as well. So what is serverless? Serverless is really about building and running applications without the need to provision or configure servers. So now your application developers can really focus on the underlying, or focus on the business logic and not worry so much about the administration or management of servers or runtimes. Now, AWS pioneered in this field with AWS Lambda that was launched a few years ago. Now, let's take a look at some of the benefits. So the no servers to provision or configure, I think it's pretty straightforward. Another benefit of using Lambda is the continuous scaling. So now you don't have to worry about provisioning or configuring servers, right? This is kind of abstracted away from you. So questions like, hey, do I have enough VMs for the next 6 months? Am I over-provisioned? Am I under-provisioned? All that is abstracted away from you because Lambda can scale automatically in response to requests. You only pay for the resources and compute time you use. So you're not really paying for the servers that are cold or idle. And finally, Lambda takes care of the complex challenge of maintaining a highly available, fault-tolerant distributed systems on your behalf. And to get to the core of Lambda, at the crux of it is a Lambda function. So function is essentially the mechanism by which you upload your code that you want Lambda service to run. We support various programming languages. And from within a function, you can pretty much do anything you want. You can call other services. You can call data stores. So it's a pretty flexible platform. There are some limits on how long one particular function can run. But you can always have hundreds to thousands of functions running parallelly at a time. And one other thing to note here is that Lambda is an event-driven compute model, meaning there needs to be an event which is going to be triggering a function. So as you write your function, you need to specify what is the event or trigger that is going to call my Lambda functions. And today, we support multiple event sources. So and this is not the full set. This is a subset of event sources that you can set up when you write a Lambda function. And what we are really going to be focusing today from a Lambda at the Edge perspective is CloudFront. So CloudFront is a CDN, a content delivery network. Looks like a lot of you are using it today. When you write your Lambda functions with a CloudFront as a trigger, that is what really Lambda at the Edge is. Now, there are some nuances, some differences, but we'll get to that in a bit. So all the benefits we talked about with Lambda is also available with Lambda at the Edge. So no servers to provision, the automatic scaling, don't pay for idle servers, and built-in availability and fault tolerance is also available. with Lambda at the edge. But the key difference here is that in addition to that, Lambda at the edge replicates your function. Now, what do I mean by that? So you would write a Lambda at the edge function the same way you write a Lambda function today. So you have the same set of tools and capabilities. But one thing you need to note here is that Lambda at the edge today supports North Virginia as the region. So when you're logging into Lambda console, select North Virginia. But then all the experience, the developer experience is the same till the point when you publish the function. Now, the standard Lambda, your functions just run in that particular AWS region. But with Lambda at the edge, your functions are now replicated to multiple locations worldwide. Now, this is not a full set of locations. It's just more for representation. So you might say, OK, this is pretty cool. But as a customer, what is the value to you? Now, to explain that, let me take a simple example here. So assume you have a simple web application. Now, typically, any web application or website would have some sort of compute. So the compute could be a web server in EC2 instance. It could be containers. It could be functions. You need to have some sort of database, whether it's SQL or NoSQL, and storage, whether it's file, block, object. And you can always decide to serve your application directly from the origin. And that might work fine if you have a couple of users. But as your application grows, as you have users coming in from different locations worldwide, especially if, let's say, a user coming in from Australia, when you have your origin in US, the experience he or she might get would be quite different from a user who's co-located or it's close to the origin. Now, an obvious architecture improvement you can make is to introduce a CDN. So for example, you could introduce CloudFront. And what CloudFront really does is move some of the storage or move some of the contents of your web application closer to the viewers. So the content is now distributed to multiple locations worldwide. So when the same user who's in Australia tries to access your application, now that particular user can be served from a location closer to the user, as opposed to traveling all the way back to the origin. Now, that's pretty good for content that can be cached. But what about requests that would require some sort of compute or dynamic content? Now, in this world, your user who's trying to access that particular dynamic content, the request still has to travel all the way back to the origin, which is not that great. Now, what Lambda at the edge can do is not only move your storage, but you can now also move your compute, some of your compute closer to the viewers. So now, for the same particular user who's trying to access that particular dynamic content, which requires some sort of compute, you can pretty much fulfill that request directly from a location closer to the viewer. From a user experience standpoint, that's pretty great, because like the page load times, the latency to serve those requests can be dramatically improved. So having covered some of the what Lambda is, or what Lambda at the edge is, and why you want to consider using it, let's take a look at the programming model here. But before we get into that, let me just cover some of the basics. So let's say you've decided to serve your web application or your website through a CDN like CloudFront. So on the right side, you have your origin, which could be in AWS. It could be outside AWS. CloudFront is agnostic to where the origin runs. And then you have your viewers. For simplicity, I have just one viewer. But in reality, you would have hundreds to several thousand new viewers who could be coming in from anywhere in the globe. And then you have CloudFront location. Again, I'm just showing one location. Today, CloudFront has 150 locations worldwide, and that number keeps increasing. So when the viewer tries to access your content, what happens is CloudFront will automatically route that request to the CloudFront location that's closest to the viewer from a latency standpoint. And then the first time the request arrives, it's going to be, the object is not going to be in CloudFront cache. CloudFront will automatically fetch the content from the origin and then cache it and then serve it back to your end viewer. So this is a cache miss scenario because CloudFront had to fetch the content from the origin. And any subsequent requests coming in from the same user or from another user who's in the same geographic area, most likely we can serve it directly from the cache. CloudFront would not need to go back to the origin because the object is already in the CloudFront cache, and this is what is a cache hit scenario. So we covered both cache miss and cache hit. Now let's take a look at the CloudFront events in the context of cache hit and cache miss. So if you remember, earlier I mentioned that Lambda is an event-driven compute. So for your function or your code to be executed, there needs to be an event set up. So for Lambda at the edge, the events are CloudFront events. And there are 4 points in the request response flow where you can run a custom logical compute. And depending on the use case, you might choose one or more of these. The first point is viewer request. So viewer request is the event that is before, it's in the request path, but it's before we do a CloudFront cache lookup. I'll cover some of the use cases when you would want to use a viewer request. So this is in the request path, and this happens right before a cache lookup is done. The next one is origin request. This is again in the request path. But let's say you want to customize the request or change the request before it travels to the origin. If you want to do that, you would do it in the origin request event. Then you have origin response. Now, this is in the response path. So the origin is serving a response. And if you want to customize it further, before you cache it in CloudFront, you would leverage origin response. And the last one here is viewer response. So this is the last point before we send the response back to the viewer. One thing to note here is that the origin request and origin response would not be triggered in the cache hit scenario. If you remember, cache hit means we are serving the response directly from, or serving the object directly from the cache. So the origin request and origin response would not be triggered. In the case of a cache miss, all the 4 trigger points could be potentially called. Now, I'm going to be referring to these 4 trigger points quite a bit in the coming slides. So please try to take a mental picture if you can. So there are 2 requests in the event, in the request path, the viewer request and origin request, and 2 in the response path, which is the origin response and viewer response. Having looked at the event triggers, let's take a deeper look into Lambda function. So a Lambda function is made up of 3 core components. The first one is a handler function. This is pretty much the entry point to your logic or code. So you would specify 2 Lambda servers. This is my starting point for your code execution. Then there is a parameter event object, which is passed to your function. Now, depending on the event source, this could contain different values. We'll look at a more concrete example in the next slide. And then you have the context object, which is an interface for your code to get information about the underlying runtime. Let's take a look at a real example, a real Lambda at the edge function example. Now, one thing to note is that Lambda at the edge today only supports Node.js runtime. No, Lambda has been around for a few years. We launched Lambda at the edge last year. So we're still adding more language support, but today what we support is Node. And then again, you have a handler function, which is the entry point. You have an event object. You have the context, and then there is an additional component called callback. Callback is a mechanism by which you kind of give an indication, or you kind of let Lambda at the edge know that you are done with your code or logic. Now, the event object could contain information about the request or response, depending on what the event trigger is. And we'll take a look at that in the next slide. Similarly, if it's on the response event, the event object would contain information about the response. Then you can define your code or compute that you want to run. So you pretty much define that in the Lambda function. And finally, you have the callback. This is how you are kind of giving indication back to Lambda at the edge that you are done with the processing. I know this is difficult to read, but we have the full example in Lambda at the edge documentation in CloudFront. But the idea here is that if you look at this, you pretty much have access to all HTTP properties in your code. So things like, what is the IP address of the end user who's trying to access my content? What is the HTTP method? What is the URI they're trying to access? What are the HTTP headers that's coming in from the client? The cookies, the query strings. And also, recently, we launched the capability to give you capability to access the actual payload of the body. So if your end viewer is making a put or a post request, the actual payload can also be accessed in your Lambda at the edge function. And in addition to that, you also have access to the config object, which gives you more information about the CloudFront distribution that is actually calling this particular function. And similarly, if you look at the response event, you have the config object, which gives you information about the distribution. And you also have a bunch of information like what are the headers, the HTTP response headers, the cookies, what is the status code that the response, the origin returned back. One thing to note here is that in the response event, you don't have access to the response body. In the request event, you have access to the body or payload that's coming in from the end viewer. But you don't have access to the origin response directly in the function today. All right, so let's take a look at a simple example. So let's say, depending on the location of your end users or viewers, you want to send the user to a more appropriate origin. Let's say you want all users in, what do we have here? All users in UK to go to a origin that is kind of designated or built for customers in UK. So what you could do is you could leverage the CloudFront viewer country header, which is an HTTP header that CloudFront makes that provides to you, and that would contain information about the location of the end viewer. So you could access the CloudFront viewer country header in your Lambda.dh function. You can figure out which country the user is in, and then you can update the request to now go to a different origin. So in this case, I'm updating the domain name and the host header to go to the appropriate origin. So now let's take a look at the use cases. Now, Lambda is like open programming platform. You can pretty much run any code you want. So while I was trying to put this section together, I tried to go back to the different customer conversations I've had over the last year and a half and tried to select, cherry pick a few of them and try to categorize them into different sections here. First, let's take a look at some of the use cases around security. So we had this customer who was in a regulated kind of industry, and they got a bunch of requirements from within their security team asking them to do a bunch of stuff. And one of them was to implement HSTS and course headers. And that should be a pretty straightforward thing for a customer to implement in the origin. But their challenge was their application is kind of in a maintenance mode. Or it was legacy, and nobody wanted to touch it, and it was difficult. Like, they didn't want to kind of do that. So what they did was they leveraged a Lambda at the edge. So their origin, their application didn't have to change. The origin just responded as it responds today. But then they had a Lambda at the edge function in the response path, an origin response function. What it did was it intercepted the response from the origin and inserted the appropriate security headers. And then since this happens before the cache, the headers inserted were also cached so that subsequent requests coming in could be served directly from the cache. This is an example of how you would do that. So here you can see in your Lambda.dh function, you can access the event object. So if you remember, the trigger is origin response. So the event gives you more information about the response. You can access the response headers. You can insert a new header with the appropriate value and then generate the response. We do have a blog post that was written which walks you through the entire process with step-by-step instructions and some code samples. So if you're interested in learning more about it, please do take a look at that particular link. All the slides are going to be available to you shortly, so even if you're not able to take a picture of this, it's fine. Another one is securing access to the origin. So let's say, so we had this customer who wanted to distribute some sort of media, and this was a premium paid content, so they want to restrict who are the end users who get access to it. Now, CloudFront today out of the box has capabilities like signed URL and signed cookies that you can use in the front end, so that any user who tries to access the CloudFront cache, you can make sure they have the appropriate permissions. And similarly, for the latter part, from the CloudFront cache to the origin, there are mechanisms like S3 OAI, which is Origin Access Identity. So if you're using an S3 bucket, you can use OAI to kind of secure that part of the connection. I mean, this is on top of HTTPS. It's essentially ensuring who gets access to the content. But if you're using a non-S3 origin, you can use custom header capability of CloudFront to pass a shared secret and kind of use that as a mechanism to kind of validate who gets access to your content. No, but we also have heard from customers who might be using some sort of custom web service and they want a custom signing mechanisms. So in those kind of use cases, what you can do is leverage a Lambda.dh function. Again, you'll be leveraging origin request because you want to kind of modify the request just before the request is sent out to the origin. And your Lambda.dh function in the origin request can then sign it appropriately so that when the request lands at the web server can do the necessary validations. There's a blog on this, with some code samples, so feel free to take a look at it if you're interested in learning more on that. A quick quiz. So authorization. So the idea here is that you have a request coming in, and you want to make sure you only allow the authorized users to access your content. What would be the appropriate Lambda at the edge trigger to use? Anybody want to give it a try? I'm sorry? Viewer request, yes. So that's the right point. So you would be leveraging viewer request because viewer request gets triggered even before the cache hit or cache lookup is done. So the idea, let's say you're using JWT, JSON Web Tokens as your authorization mechanism. And the idea is that when a request comes in, you want a Lambda at the edge function to be triggered. And this Lambda at the edge function, depending on whether the user is authorized or not, would allow the request to continue or not. So if it's a valid user, you would allow the request to continue in its path. On the other hand, if it's not an authorized user, you can immediately generate a response from your Lambda at the edge function. So you could have an access denied, or you could redirect the user to an authentication page. Now, interesting thing about this is that you're kind of moving. So if you didn't have Lambda at the edge, you kind of would be doing all this logic in your origin. So you're kind of moving logic away from the origin. You're offloading work from your origin to distributed serverless functions that are running in multiple locations. So your origin can now be greatly simplified. For example, if you're getting an attack, all that attack traffic is kind of handled and scaled by CloudFront and Lambda at the edge, and your origin is shielded from all these kind of traffic coming into your to the origin. Again, there's a blog post if you're interested in learning more on that. This was actually a pretty popular blog post because it gives you an end-to-end picture. It talks about how you can do the authentication also with other AWS services like Cognito and such. You could also have applications where you could really not do stateless authorization, meaning that you need to make a call to an external service or store which has a state. Again, that can be done with Lambda at the edge function, and that capability is available because your Lambda at the edge functions can actually make a network call. So you can make a HTTP call to any external service. It doesn't have to be in AWS. It could be anywhere. And then that external service could give the decision of whether the request should be allowed. So if the request is allowed, you just allow the request to continue in its path. If the request is not allowed, you could then serve access denied, or you can deny access to that particular user. So we looked at a bunch of use cases related to security and securing your content. Let's take a look at what you can do with, or how you can customize the content. Now, template rendering is a pretty interesting one because in this particular use case, you don't even need to have an origin. You're pretty much doing all your compute directly in Lambda at the edge. So the idea here is that, let's say you have a template, which is probably the same for all users, and then you're kind of personalizing it to a user with some dynamic content, and this dynamic content could be residing in a different location or different service. You're trying to map or putting both the data together and then serving the response to the viewer. So let's see how you can do that with Lambda at the edge. So again, you can have an origin request event, which could make multiple calls. So you can make multiple network calls to multiple endpoints. So you could store your template, which is pretty cacheable on an S3 bucket. Or if you want to optimize it even further, you could actually store your template in another CloudFront cache behavior. So essentially, your Lambda function is making a call to S3 bucket. It gets the template. It makes a call to DynamoDB or some other data store for the dynamic content, and then you're putting the data together, and you're serving the response directly from the origin request. So in this particular scenario, you don't really have an origin. You can pretty much use your Lambda at the edge function as the origin to fulfill the particular request. So this is what the code sample would look like. Now, if you notice, you have access to the AWS SDK in Lambda at the edge function. Also, you could bring in your own libraries if you would like. And you can make a connection to S3 bucket. You can make a connection to DynamoDB, put this data together, and serve the response back to the viewers. Another example is personalization. Again, this falls in the category of originless kind of application or use case. So you could have an origin request function which gets triggered and which could then inspect either some particular header like the accept language or one of the headers which CloudFront makes available, and then you can kind of serve a very personalized version of the site to the user. So I believe I have an example here. For example, this is similar to the example I shared before. So depending on the country code, if they are in UK, In that particular, the previous example I shared, we were generating, we were kind of updating the origin which we were sending the request to. But here what you're doing is you're generating a redirect response directly from your Lambda at the edge function to a more appropriate, personalized page for that particular user. This again falls in the category of personalizing your site for the user. So the idea here is that you might have users coming in from different kind of devices, so small devices like phones, desktops, larger devices like desktop and laptops. And as an owner of the website or application, you want to kind of give them the most optimal user experience, right? You don't want to say serve the same image for all kinds of devices. And you could always pre-render different resolutions of image and keep it in your storage. And that might work fine. But we have also heard from customers who, there was one customer who had, I forget, but they had a large number of images. And many of them were not accessed frequently. So from a cost standpoint, it didn't make any sense for them to pre-render and create all these different combinations of images. So what they did was they leveraged Lambda at the edge. The flow is, let's say the first time the user tries to access an image and, with a particular in a particular size or resolution. CloudFront will try to fetch the content from S3, and let's say that particular image in that particular resolution is not available. Origin response function would get triggered. It will say object not found. And what the origin response function could then do is it could make a call to S3, fetch the raw image. It could resize the image, store the resized image in the S3 bucket, and then serve the resized image back to the viewer. So any subsequent request for, from a device similar to the previous device would be a cache hit and would be served from the CloudFront cache. Again, we have a blog post. This was another popular blog post among viewers where there are some interesting, there are some optimizations you can do, and the blog post covers all of that. Another example is visitor prioritization. So let's say you have applications where, for whatever reason, you cannot scale your application to meet a sudden spike in traffic, or if you want to kind of segment your users across different origins. So what you could do is use a Lambda at the edge function, origin function, which could then maybe look at a cookie, which kind of could be the indicator whether this is a prioritized user or not, and then route the request to the appropriate backend. Cache key customization, this is a pretty interesting one. So CloudFront today, when the cache key that is used contains the URL of the object that's being accessed. And that works for a lot of the use cases. But we had this customer who was distributing media content. And in their case, the URL had the playback. I kind of simplified the use case here. But the thing was they had playback session ID in the URL. So let's say they have 10 users all trying to access the same movie, for example. There are going to be 10 entries in CloudFront cache because all of them, even though they are all accessing the same object, has 10 different unique URLs. And they were logging these URLs, and they were using CloudFront access logs for later processing. So the idea is that they wanted to send a bill at the end of month or whatever. So they wanted to keep a track of all these. Now, while this worked for that particular use case, it was not very good from a cache hit ratio perspective, right? Because your cache key is really diluted now. And what they did was they leveraged Lambda at the edge function. They had a viewer request function. Again, if you remember, viewer request is the first point. It gets triggered even before the CloudFront cache lookup is done. And what the viewer request function did was, if you look at the original URL, the original URL had that playback ID just before file 1. And they rewrote the URL to kind of take that off. But that information was still logged so that they can do the chargeback at the end of the month. But the URL was now much more simpler. So from a cache key perspective, they had the simple URL. So any user who's trying to access the object points to the same cache key. And the end benefit for them was that the cache hit ratio got much better than before. All right, so now let's take a look at a few different use cases in what I call as the content-based routing. So the idea is that you could have multiple origins in the backend, and you want to kind of route the request to the appropriate backend origin. The way you could do that is leverage a Lambda at the edge function. It could either look at something within the request, so it could be header or query string or cookie, or it could make a call to external data store and then route the request to the appropriate backend origin. There are a few different use cases that fall in this category. OK, I don't know what's happening. Just jumped a bunch of slides here. Sorry about that. OK, I'm almost there. So we had this customer who were delivering APIs for Winter Olympics, this year's Winter Olympics. And at the beginning of every event, like any sporting event, they would get a big spike of customers coming in. They wanted a way to kind of distribute their traffic across 2 origins in Europe. They were mainly catering to European customers. So what they did was they had a Lambda ADH function which inspected a particular custom header. And then that header kind of gave an indication of what is the best origin for that particular request. And then they routed to the appropriate backend origin. Data locality or low latency is another reason. So let's say you have multiple buckets in different regions. And let's say you want, for all users coming in from Germany, for example, you want to make sure they go to their Frankfurt bucket. Now, this cannot be done natively with Route 53 because of some limitations of host headers and S3. But when you leverage Lambda at the edge, what you can do is you can have a Lambda at the edge function which would look at the appropriate value in the request and then route it to the appropriate appropriate backend origin. Another example is A/B testing. Let's say you're launching a new feature or a new version of the application, and you have the new version. Let's say it's origin B. And now you want to send a percentage of your users to origin B and kind of gradually dial that up till you have full confidence, and after which you would completely cut over everyone to origin B. So you can kind of achieve those kind of use cases with Lambda at the edge. So you could have an origin request function. You could use cookie as a mechanism to kind of track which session the user is in. First time the request comes in, let's say there's no cookie, and you could have your logic define which origin it should go to. You could set up the cookie so that any subsequent request coming in would have that cookie set, and Lambda at the edge function can then inspect the cookie and send it to the appropriate backend origin. This is just an example of how you could update or update your request so that you go to a new origin. One thing to note here is that especially when you're using an S3 bucket, you need to update the host header, and this is why you are able to kind of route between different S3 buckets. So I had this customer who was one of the early adopters of Lambda at the edge, and they had this use case where they want to send all good bots, so Google, Facebook, all the search engine traffic, they wanted to send to a pre-rendered version of their website. Whereas real users, they want to send to their origin application, and all bad bots, they just want to discard. So they leverage Lambda at the edge. So you have access to the user agent header in your Lambda at the edge function, and you can inspect that and then route the user to the appropriate backend origin. And origin failover, so this is a capability we just launched last week. So you can do origin failover even without Lambda at the edge. So let's say you have 2 S3 buckets, and you designate one bucket as the primary bucket and the second bucket as the secondary. And what you can do is pretty much use CloudFront to automatically fail over to the secondary when the primary is not available. So you can define the error condition when you want to do the failover, and then CloudFront will automatically route the request to the appropriate, or would automatically route the request to the secondary origin when there is an issue. And if you want to further customize it, you have access to Lambda functions, which can do that for you. So with that, let me invite Tyler to share Sentient's use case.
Cool. Thanks, George. Is my mic working, or is it cutting out? I'm good? All right. Cool. So as George mentioned, I'm Tyler Foster. I'm VP of Technology with Sentient Technologies. You probably haven't heard about us, but you've probably experienced websites or other solutions that have been optimized by our technology. So there are a lot of ideas in the world today. a lot of new business models popping up, new technology that are leading to changes in user behavior and user expectations near daily. So previously, using kind of standard A/B testing and going through a large design process led to enough throughput of new ideas to keep users engaged. But today, with the speed at which things are changing, it's getting harder to keep up with user expectations and user behaviors. So Sentient Ascend allows you to basically optimize on the fly through online learning with a combination of machine learning approaches, mainly around evolutionary computation. So through evolutionary experience optimization, Ascend's able to collect a bunch of ideas, thousands potentially of ideas from the end user, pile them all into a big pool, sort through them to find the optimal combination of ideas for the end users, customers, whatever they're looking to do. With that, we use genetic algorithms to search and find the local and global maxima to optimize that user experience. So that's the context. And basically, as you can guess, we have pretty stringent requirements. So if we don't land on the page fast enough, then it will negatively impact the user experience and negate the benefits of the system. Also, we see a lot of variation in traffic depending on who's experimenting, what they're experimenting on, changes that they're making. So we have to kind of accommodate all of this. Previously, we had a system that was 7 regional spokes, as we called them, each of which was 3 to 10 M4 large nodes backed by 3-node elastic cache clusters. It was really complicated. It was hard to scale. And if you weren't within a reasonable distance of one of those 7 regions, we hit serious latency issues. So we went back to the drawing board to figure out a better way. It just so happened that it was right around the time that Lambda at Edge was launched. So we were able to simplify that complex system into two Lambda at Edge functions that feed data back through the CloudWatch logs. So it's part of a larger architecture that looks something like this, where basically the CloudWatch logs are fed through Kinesis Firehose into transform lambdas that then store it in Parquet format on disk. So I'll walk through some of the challenges of doing this that we faced with each of the different Lambda at Edge instances or functions. But first, this is kind of a more detailed walkthrough of our request flow. So as you can see, the request comes from the runtime client or SDK. It hits the cache, runs the Lambda at Edge function, which then determines the correct combination of variations to deliver, then reroutes them back through the CloudFront cache to an execution plan associated with that combination, finally delivering the end result, and then collecting events about it, which it feeds through Lambda at Edge back into our data pipelines. And the results were pretty impressive, actually, far better than we had expected. So we started to roll it out on the 1st of August. We cut costs by more than 50%. Then we doubled our traffic, and the results stayed pretty stable. We didn't run into a lot of throttling or anything, which were some of our original concerns. We had a couple of throttles early on under heavy load, but we were able to be resilient to those and kind of gain the overall goals that we had set out to achieve. So the first Lambda function that I'm going to talk about is our allocation function. This one does a lot of different things, but primarily it's bot detection, traffic filtering with the goal of allocating to an experiment, and then content negotiation. So first, here's a JavaScript module that provides just sort of quick and dirty bot detection. We found it really good for doing quick and dirty bot detection, but doing full bot detection was really, really hard. It was very expensive. The runtime bogged down. This slide actually has been struggling to render just because of the syntax highlighting. So it's not really a great option for doing full bot detection, but you're welcome to give it a try if you want to. Also, doing traffic filtering. So there's a lot of data that's available at the Lambda at edge execution, both on the viewer side and the origin side, more so on the origin side, just because on the viewer side, you can access data, like, for instance, location information. So you don't know the country that the request is coming from in a viewer triggered request. Anytime that you're going to be accessing headers or want to access headers from your Lambda at edge, be sure to whitelist them or set to cache on all headers, because otherwise you won't have access to them in your Lambda. This was one thing that kind of kept on biting us, was we'd see a bug and then we'd say, oh, wait, what's going on? And we'd find that there wasn't that specific header whitelisted. From a content negotiation perspective, you can do a lot of stuff based on content routing. So either the URI or different headers, be it the language header or content type. We do negotiation based on two things. So we might send JSON payload, or we might send back a JavaScript payload. And then also, that is specialized for that end user. So it's going to be a specific combination of variations relative to the user's characteristics. Should I pick up the other mic? No, you're good. OK. All right. You can also rewrite the whole origin. This is something that George talked about. It's really easy to do, and it can be helpful in a lot of different situations, particularly around proxying. We found it helpful. So we found that access to data in the origin request was really good, but it was after the cache hit or the cache check already. So we've had to use this pattern several times, where we'll actually set another behavior as the origin to an original request. So whether we're accessing template files or we're accessing API calls, et cetera, we'll often plumb them through another behavior in order to cache it near the actual Lambda that's executing. OK, so here's our Lambda at edge function. This one is our events function, which is responsible for collecting all of the data about participants in the micro experiments that we're running constantly to identify the optimal combination of variants. The basic flow is this. So the request comes into CloudFront, which then hands it off to a Lambda at edge, which parses it, logs it to CloudWatch. We then have a CloudWatch subscription that pulls it into Data Firehose, which then copies it to disk in S3, runs it through a Lambda transform, copies the final files to S3 in Parquet format, and then we can query it through Athena. This has worked out to be really good for us. The performance is great, really cost effective, far more effective than our previous solution of using Elasticsearch for this sort of workload. So some handy things here. Just recently, they made it available to access the request body, which was a significant limitation before. So this is really helpful when building APIs at the edge. Whenever you're using, or whenever you need to access the body, be sure to check this box or the one in the Lambda registration, or set it up in your Lambda at edge configuration. Another situation was doing cross-site requests. So a lot of people will totally avoid cross-site requests because of the pre-flights, which are an origin, or an option call that precedes actual request, which can add a lot of latency to your response times. So this can be really handy when building APIs at the edge that will be called cross-origin. Basically, if you define it in a way that is considered a simple request by the spec, then it will avoid the original options call and just make the call directly. Then just set the access control max age header, and you should never face the latency of the core's pre-flights. Another cool trick that we have used is doing content validation with JSON schemas at the edge. So basically, no matter what the schema is that you've, or the MIME type is that you've delivered in, whether it's URL encoded or JSON, if you use the JSON schema libraries, you can just parse it and then run the validation against the parsed result, which is really handy when you're trying to push a lot of data through the edge. One of the hardest things that we faced through this was when a Lambda at edge function executes, it only logs in the region where the executed. So, and it won't create the log group until it's executed there. So you kind of play whack-a-mole chasing the log groups around. So we wrote another Lambda function that's triggered on a log group creation, which then goes out and picks up the and registers the subscriptions when a new log group is created. When you're logging the data, it's really easy to parse out. The log information that Lambda at edge produces is really helpful. You can, and if you just log it in JSON format, it's to write subscriptions for. There's also other good information in these logs, like it'll tell you exactly what you paid for that request, or at least the number of milliseconds billed and the amount of memory build, which gives you a good option for customer chargebacks and things like that. And then kind of final tip, use the Parquet serialization that is built into Lambda Firehose if you're going to be using Athena. It's way more efficient, it's easy to set up, and it saved us a lot. So this was going to be complex to implement ourselves, and this isn't a Lambda at edge feature, but it was a cool feature of Data Firehose that saved us a lot of time. So thank you, everyone. That's it for me. Again, I'm Tyler Foster, VP of Technology at Sentient, and George Sean was my co-presenter, product manager.